Hello Year 8. Today we are looking at non-linear graphs. So the whole topic so far has been dedicated to straight lines. In this last little section we just want to have a brief look at something that is not straight, and more specifically a specific type. We're going to look at something called a parabola. So the equation of a parabola will be in the form something like y is equal to x squared. We could put some extra numbers in there or some minus signs, but you will always see that x squared in there somewhere if this is going to be a parabola. And this is a curve or a non-linear graph. So just like we did with the straight lines, to see what this looks like, we're going to start by filling in a table of values. So our first equation, we're just going to start with our very basic one, y is equal to x squared, and we're going to fill in this table. So if x is equal to -3, that means I want to put in my calculator -3 squared. Now the mistake that some people make when putting this in their calculator is to do this. They go -3 and then they put the squared there like that, and then they get the answer of -9. Okay, that's actually incorrect, because when I square the -3, I want to make sure that my calculator squares the minus as well. So I have to put it in brackets. And you'll see the difference when I put the brackets around that -3. So it's -3 in brackets, and then I square it. Then I get a +9. Okay, so just remember that's a little tidbit, a little bit of information there. If you are squaring a negative number, put brackets around it first. So -3 squared is 9. Now let's move on to -2. So we want negative, we're just going to delete that and put it at 2. So -2 squared is 4. -1, so you might know some of these without your calculator. -1 squared is 1. Then 0 squared, what do you think 0 squared is? 0 squared is 0. And then on to the next one. Then we want to do 1 squared, which is 1. And then 2 squared is 4. And then finally, 3 squared is 9. So you can see there's a bit of symmetry to these numbers that are in here. We have 9, 4, 1, 0. And then it starts going up again. 1, 4, 9 has the same pattern but in reverse. Okay, we're going to draw that on this Cartesian plane down below. So we need to set this up. Make sure you're using a ruler. So we have a vertical y-axis and a horizontal x-axis. Try to get it in the middle as much as possible. So x and y, please remember to label everything. We need some numbers. Actually, I'm not going to change those numbers going across there. I'm going to space it out a little bit more. I'm going to go every second space just to make it not quite so squished. So every second line, I'm going up by 1s across the x-axis. On the vertical axis, though, I'm going to have to stick to going up by 1s to make it fit. And I'm going to need some -1s as well. Okay, so now that we have the Cartesian plane drawn, looking at my table of values, when x equals -3, y equals 9, put a dot. X equals -2, y equals 4, put a dot. X equals -1, y equals 1, put a dot. 0, 0, put a dot. 1, 1, 2, 4, and 3, 9. So you can see that it's definitely not a straight line. If we start with the vertex and we curve our graph going up to the left and curve going up to the right, that is the basic shape of a parabola. Okay, let's look at the next one. Question 2. It says, y is equal to negative x squared. What does putting that negative sign in do to the graph? So let's go back to our calculator. We have a minus sign in front of the x, and I want the x to be a negative 3 squared. So the negative 3 that I'm putting in is in the brackets, but the negative is in front of that, and that gives a negative 9. Then I want to change to negative 2. So we get negative 4, then negative 1, it's negative 1, 0. Oh, we don't need a minus sign there for 0. So 0 squared is 0 with a minus in front of it, still 0. And then on the other side, when we get to a positive 1, our pattern starts repeating. We're at negative 1. So the next one's going to be negative 4, and the next one's going to be negative 9. Okay, so then drawing that on our Cartesian plane, at negative 3 we have negative 9, negative 2 is negative 4, negative 1 is negative 1, 0, 0, 1, negative 1, 2, negative 4, and 3, negative 9. And joining from the vertex, we call it, of the parabola, the top part of the parabola, and sloping down on the left and the right hand side of that. Okay, so what the minus sign in front of the x squared did was reflect the graph over the x-axis. It still had the same shape, but it reflected it over. Okay, so on the next page we have a couple more examples. Let's fill in these tables. So our equation, for example, 3 is y is equal to x squared plus 3. What does adding that number on the end do? So we're going to have a bracket so that we can put a negative 3 squared and then plus 3. So our first value is 12. Then we're going to change to be a negative 2 squared plus 3, so 7. Then we change to be a negative 1 squared plus 3, so that's 4. And then 0 squared plus 3 is 3. And after that, this is when it starts repeating. When I go to 1, it's going to be back to 4 again. So 3 was the lowest point. So we had 12, 7, 4, 3, 4. Then it will be 7, 12. I'm going to fill in the second table here before I draw both graphs. So let's look at the next one, which is y equals minus x squared minus 4. To type this in, we have minus, and then x squared will be minus 3 squared in brackets, and then minus 4. So that's negative 13. Then let's change that to be a minus 2. Then change it to be a minus 1. Then change it to be 0. And then it will start repeating the pattern. So we're back to minus 5. Then it will be negative 8 and negative 13. Okay, so let's draw up our Cartesian plane with our ruler in the middle if we can. So we have our x-axis and our y-axis. Again, I'm going to stretch my x-axis out a little bit so that it's not too squished up. We have 1, 2, 3 for the x, negative 1, negative 2, negative 3. But vertically, I have in my first table numbers going up to 12, and in my second table they're going down to negative 13. There is not enough space to be going up by 1s in that grid there. So I'm going to need to go up by 2s. So 2, 4, 6, 8, 10, 12, and that will be enough. and then going down, -2, -4, -6, -8, -10, -12, -14. Now, it is okay, just a reminder, you can have a different scale on your x-axis to your y-axis, but you can't have two different scales on the x-axis. I can't have going up by ones on the top and down by twos on the bottom. Okay, it needs to be consistent, otherwise your graph will look very strange. Okay, so looking back to our table of values, the first one, our first point was -3, 12. Let's put a dot there. -2, 7. -1, 4. 0, 3. 1, 4. 2, 7, 3, 12. And join it up. So it had the shape of the first parabola that I drew, but instead of the tip of the parabola being on the origin, it has moved it up, and it's moved it up 3 places. So that +3 that's on the end of my equation moves the whole parabola up 3. So it's interesting little things that the different numbers, where they're positioned, how they're going to move the graph around. Okay, now let's switch and draw the second table. So at -3, it was -13. Then -2 is -8. -1 was -5. 0 was -4. Then 1 was -5. 2 is -8. 3, -13. Okay, so this was y equals -x squared minus 4. So the negative in front of the x squared turns the parabola down, and the -4 has moved the point of that parabola down to -4. Okay, so that's our introduction to parabolas. There is a lot more that can be done with parabolas, but we'll be doing that in future years. Your turn to practice drawing a few of these in exercise 12.